Welcome to the virtual presentation of the Institute of Mechanism Theory, Machine Dynamics and Robotics. I'm glad that you found your virtual way into our building, into our laboratories. My name is Burkhard Korvis. I'm the head and chair of the Institute of Mechanism Theory, Machine Dynamics and Robotics. And I hope you will have a wonderful tour around our labs. You will see what we are doing in mechanism theory. You will also see what we are doing in robotics, and of course also what we are doing in machine dynamics. So welcome, and Professor Hüsing, who is the second professor at the Institute, he will guide you through this virtual tour.
Thank you, Burkhard, for your introduction. My name is Matthias Hüsing. I'm also professor at this Institute of Mechanism Theory, Dynamics of Machine and Robotics. And I also welcome you to this virtual guided tour. Why do we use this format of virtual guided tour? Because generally we would like to show you our institute in reality, in presence. Unfortunately, this is not possible for the moment. So we choose it to show you the Institute virtual. Where can you find us? We are situated, or we are at the Alfschornsteinstraße 18. It is the faculty building, and we are in this building in the ground floor, where I am now, in the third floor, and in the fifth floor. In the fifth floor, there are the most of the assistants, there's the secretary, and me, and Burkhard Korvis. I hope that this virtual tour, this virtual guide, will show you a little bit what we're doing. So later, hopefully you come here to make some thesis, master thesis, mini thesis, and that we can work together in order to make advanced robotics, kinematics and dynamics. Now let's go, and we go to the building Alfschornsteinstraße 18. Come with me, we are driving. Yes, and to show you how you reach us, I went in the elevator of the building and I took with me a flying robot, a drone, and then I got up to the fifth floor where most of the colleagues are, where most of the assistants are, and where the secretary are, where me and Burkhard Korvis are located. At the fifth floor, at our entrance, it welcomes you a showcase cabinet wall. You see there are a lot of kinematic models, of mechanism models within this wall, colored and telling you stories about it. But now, tell me something about our institute, and I warmly welcome you to come with me and to see what we're doing. Let me begin with some slides regarding our institute on this virtual tour of this institute. The Institute of Mechanism Theory, Machine Dynamics and Robotics was founded in 1959, so some years ago. We are located, of course you know it, at Aachen, and here you see our building in Alfschornsteinstraße 18. Guided is this institute by Professor Korvis and me. Our team. We are 2 professors. We are 20 research assistants, 3 guest scientists. We have 8 non-scientific staff and 2 trainees. And we have at about 60 student assistants. These assistants are students like you who are in former semesters, and they can do research or they help in education and they get the money by doing this. Our lecture reaches over 2,000 students per year, and our annual turnover is approximately by 2.5 million euros, which are generated in 3 sectors. These sectors are teaching, research, and industry. Let's talk about our structure and our research field. One of our research fields is mechanism theory and kinematics. What does this mean? This means creating desired motion. The design of mechanisms and robotic systems for special motion tasks is in this focus. And the focus here lies on non-uniformity, transmission behavior. The second field is the dynamics of machines and vibration technology. In this case, we like to avoid undesirable motions. We model multi-body systems. We're making vibration analysis. We are researching in methods of vibration reduction and damping, and so on. And the third and biggest field, research field of this institute is within robotics and mechatronics. We're coming from the mechanical side, and we are, so to speak, we develop, we analyze and control robotic systems. These robotic systems for serial, parallel, hybrid robots, but also mobile robots. Here we're focusing on synthesis, control, predictive control, parameter identification, and also gripper systems. Redundancy and reconfiguration we also include in our research. What courses do we have? Our education. First of all, we have one basic course or lecture for the 3rd semester of the German bachelor. It's about machine design. Then we have also a bachelor course called Electromechanical Drive and Motion Technology. Here are the basics of mechanism theory together with electric drives. Then we teach fundamentals of machine and structural dynamics. These are more or less the fundamentals of vibrations. Then, as a master course, we teach advanced motion technology. This is a little bit higher mechanism theory. And then we're teaching multi-body dynamics in German, but also we do teaches in English. And then we are teaching applied design and product development, 1 and 2. It's a 2-semester course in the Master of Product Design or Product Development. And here within the students, they have a task from industry and to solve in the first semester the design, the principal design, and the second semester they make some more regarding detail design and in order to develop this product. And then we also are involved in industrial assembly systems, partly. We have English taught lectures. One of the lecture is Machine Dynamics of Rigid Systems. Within this lecture, the students learn how to balance mechanisms, make mass balancing and power smoothing. Then we have another course called Multi-Body Dynamics. Then we have a course called Robotic Systems. Here are the bases of robotics introduced for students: structures, controls, mobile robots, gear technology, and other things. And then we have a course or lecture, Advanced Robotics, Kinematics, and Dynamics. And then we have some laboratory also in German, metrology laboratory, a small group exercises in atoms, and small group exercise in MATLAB, and colloquium for the internship semester. This is for the German students. This is our portfolio for education. Now coming back to the three groups: mechanism theory, dynamics of machines, and robotics. In the next minutes, I have the pleasure that the group leaders of these groups will present you some cool research topics. And I welcome you to hear them and listen them. Thank you. Mrs. Merz, please.
Thank you very much, Matthias, for this introductory words. Also from my side, a warm welcome to the virtual tour of IGMR. My name is Judith Merz, and I'm the team leader of the Mechanism Theory and Kinematics group. Since the foundation of the Institute, mechanism design has been a mainstay at IGMR, and today it is one of the few institutes in Germany with this focus. We try to make our knowledge of mechanism theory available to a broad engineering public, e.g. with the development of the mechanism software MechDev. And we aim at a wide range of functions with easy-to-use software ergonomics. Our representation of planar mechanism by means of revolute joints, sliders and cams support a kinematic and kinetostatic analysis and enable simple optimizations via drag and drop. We use this knowledge in our wide range of industrial and research projects. Using cam plates, as shown in MechDev, we have developed a so-called mock heart. For medical technology, the movement of a human heart was digitally recorded and then reproduced in 3 planes by moving 8 cams each. In another project, we are using the design of a 5-bar mechanism as a haptic feedback system, shown here as an example for a conventional kitchen cabinet. Without having a kitchen cabinet, the movement and the effort required for the real user can be simulated. The system can be transferred into other movement devices as desired. Newer topics with many intersections to mechanism theory and kinematics are also researched at IGMR. For example, working with and testing compliant mechanisms. In life cycle tests, compliant mechanisms with different material properties are tested until fatigue failure. But also, origami-based movable foldings are a research topic at IGMR. The smaller units of the folding, the vertices, are similar to spherical mechanisms in their properties. Larger structures of the folding consist of many loops in their kinematic chains, can have a high number of degrees of freedom, and are complex in their form of motion. We investigate all this and more in our mechanism theory and kinematics group. This brings me to the end of my short presentation. I hope you enjoyed it, and I would be very pleased to be able to welcome you in real life sometime here at IGMR.
Mr. Archut, please.
Thank you very much for the introductory words, and also from me, welcome to our virtual tour of the Institute. In the group Dynamics of Machines and Vibration Technology, we deal with the application and also with the development of procedures and methods for the simulation-based dynamic design and optimization of mechanical systems. One of our largest fields of activity is multi-body simulation. Here, on the example of the project Determination of Load Collectives using Multi-Body Simulation, in cooperation with Siemens. To meet the demands for greater efficiency, cheaper routes by avoiding tunnels and less route damage, modern trains must become ever lighter. In order to be able to develop safe trains despite lightweight construction, knowledge of the loads acting on the components of the train during its service life is required. The goal of this project is to be able to calculate these loads precisely and efficiently by identifying real scenarios from measurement data and reducing them to representative basic scenarios that we can simulate and extrapolate with little computing effort. Of course, the knowledge developed in this process can also be applied to other vehicles. Today, bicycles are still mostly built according to the principle of trial and error. In the project Multi-Body Simulation-based bicycle design, we have built a multi-body simulation model of a full suspension mountain bike and can use it to simulate the loads and also the design with regard to the riding behavior when the geometry or the suspension is changed. All simulations are of course validated by test benches and measurements. Finally, I would like to present a project from the field of vibration technology. In the project ZIMUS, we are dealing with the development of new monitoring strategies for ultrasonic welding processes. In ultrasonic welding, the parts to be joined are welded by a longitudinal oscillation of a so-called sonotrode and simultaneous pressing by a pneumatic force unit. The process is characterized by a very low energy input and makes it possible to weld materials of different types, such as copper and aluminium, as you can see here. This makes it very interesting for electromobility and battery production. One drawback, however, is that there is not yet an adequate monitoring procedure to control the quality of the weld. Our results show that by monitoring the anvil vibrations, conclusions can be drawn not only about the quality, but also about the material and surface properties. We are now trying to automate this by means of suitable machine learning algorithms and thus build a monitoring system. Thank you very much for your attention.
Mr. Haschke, please.
Hello together, my name is Tobias and I would like to take you on a little virtual tour through the robotics group of our department. When we at IGMR talk about robotics, it also means that we really build our own robots. Here in the video, you can see the paragraph handling system developed by us. It is particularly suitable for handling large and even flexible components. Besides building new robots, we also develop new applications. For example, here the so-called 5D printing or multidirectional additive manufacturing. Robotics for us also means that we develop new algorithms, especially sensor processing algorithms, path planning, or trajectory planning algorithms. Here in the example, we see the image of a depth camera in the upper right corner. On the left side, the scenario we have built up to track a person in space, to follow him continuously and to determine his pose. Even if, as here in the picture, various other people enter the room, we can still follow the original target person. The algorithms just mentioned include planning algorithms. Here in this picture, you can see a simulation in order to carry out so-called task and fleet planning. This means that we have a set of tasks to be performed and a fleet of available robots that can perform them. And now it is all about executing all tasks as efficiently as possible and achieving a good result. An important step in the development of algorithms is always the continuous and consistent validation. Here is a picture of the semantic mapping developed by us. The 3D perception and semantic mapping of any room, such as a living room in your home, The resulting point cloud, which we can see here in the picture, is brought together from both rooms, then segmented once. In example, we distinguish which different components as walls, ceilings, floors we have determined and later built them together in a so-called cluster object. Yes, and sometimes the validation of our algorithms is a bit more complex. What you see here in the picture is a room that we have fogged ourselves. We have used a classic fog machine to test a radar-based localization and mapping algorithm. This was particularly necessary because we wanted to access rough environments, accordingly in poor visibility, such as fog, smoke, clouds, or heavy dust. And here in the picture, you can see that the robot can move safely around the obstacles despite poor visibility, and no matter how much fog we add now, it can still follow its path and trajectory continuously. A particularly exciting approach in mobile robotics. And finally, an example why it can be quite motivating to decide for robotics. With new automation applications, you can also contribute to the health of the people around you. In the picture, you can see our Bots Direct project, which we use to remove asbestos from living spaces automatically to eliminate the danger of asbestosis. I hope I could show you how incredibly versatile the field of robotics is at our institute. You can really implement everything from design and development, for example on the mechanical side, to the sensor data processing and algorithms in the field of software. So if you are interested, I look forward to welcome you soon as a student in the courses, as a student worker, or writing a thesis.
Yes, this was our little virtual institute tour. I hope that you enjoyed this tour, and I would like to see you soon in presence. Stay healthy. Bye bye.